Morning, everybody. Thanks for having me. Like Steve mentioned, I'm a PhD student at Northeastern University, and today I'm going to talk to you guys about our development of a decision support system to aid environmental health departments after Hurricane Helene. So when I say a data decision support system, basically what I mean is GIS-enabled tools. So after Helene, we ended up launching this webpage through an ArcGIS web map, and it had available data for all of the counties impacted by Hurricane Helene. So this is the final product. I'm skipping ahead a little bit, but I'm gonna back up and tell you guys a little bit about our team, our collaboration with the North Carolina Department of Health and Human Services, and how we got to this point to be able to provide this data quickly after Hurricane Helene. So our team is a NASA-funded group of researchers with Northeastern University, University of Alabama, Campbell University, and DHHS. And this is our team here. So I'm here today presenting on behalf of everybody, but there are so many people who have been involved in this work on the remote sensing side of things, on the modeling side of things, collecting data, outreach, and I just want to take a second to acknowledge everybody who's been a part of this work. So we are a NASA-funded group tasked with developing a well water surveillance and response system for North Carolina. And so our overarching goal is to take publicly available data and data sets, including DHHS well tests, DEQ groundwater data, and combine that with some satellite and remotely sensed data products, including drought data, water level data, and land cover data to put together a GIS-enabled system where health departments can kind of have all of these tools at their fingertips. And the goal is to look at four kind of areas: enhancing monitoring and sampling efforts, targeted outreach in preparation of a hazard, targeted response after disasters, and then spatiotemporal modeling of contaminants under baseline and post-flooding conditions. So today I'm going to talk kind of about all of them, but mostly targeted response after disasters. So after Hurricane Helene, we were able to develop this data decision support system, but this was only possible because of all of the work that we've been building on for the past 8 to 10 years. I've been involved for the past 4. So I'm gonna talk through some of our work with Hurricane Florence in 2018, Hurricane Debbie in August of 2024, and how our research to that point led us to be able to help after Hurricane Helene. So after Hurricane Florence in 2018, our team conducted a study where we used Earth observations to determine who was flooded after disasters. And so our overarching goal was, how can flood mapping predictions be used to advise recovery efforts? So we used available hydraulic models, hydrologic models, and satellite-based tools to look at 3 different methods of flood mapping. The first, which some of you might be familiar with, is the FEMA 100-year flood boundary. So that is an existing map for most of the United States, derived using both hydrologic and hydraulic models to identify locations that have a 1% chance of flooding in any given year. So this is a static map that's pretty widely used across the country. We also incorporated a model that some of our remote sensing team has been developing called Height Above Nearest Drainage, HAND. So HAND incorporates reach average relationships between water depth and river discharge based on Manning's equation. So the non-fluid mechanics definition of that is, if we have a point, let's see, can I use this? Okay, it's all right, I have a little star. If we have a point up there on top of a hill and we want to know what the flow rate through that stream underneath needs to be so that point floods, we can use Manning's equation, estimate the slope of the river and the shape of the basin to see what that flow rate needs to be for that height up there on the hill to flood. And so that's kind of the base of this flood mapping approach. And as an example, here it is. We validate our estimates with stream gauge data from the National Weather Model. So if that flow rate is above the flow rate that we estimate for that point to flood, it ends up in blue there. And so that's the map that you could see after Hurricane Florence. And this is really neat because it gives us a real-time map for storm-specific events. And then this is another flood mapping tool that we used. But when we compared the 100-year flood boundary in hand, we found that these boundaries were not consistent in estimating impacts after Florence. So using the 100-year map, we estimated 35% of wells were flooded and 25% of FEMA declared areas were flooded. When you look at hand, those estimates were a lot lower, with 8% of wells flooded and 9% of the FEMA area. And so when we're going to our collaborators and we're going to the health departments and saying, this is what we think is impacted, those differences are really, really substantial. And so to try to validate which one of these were more accurate, we brought in some testing from DHHS, and we had about 3,000 tests under baseline conditions for total coliform and E. coli, just those bacteria tests, and then an additional 750 that were collected after Hurricane Florence. And we found total coliform was elevated to 41% from 35% under baseline conditions, and E. coli was almost 8 times higher than routine conditions at about 11.2%. So overlaying these tested well locations with our flood boundaries, we also found that E. coli detection varied. So within the 100-year flood boundary, we found about 15% of samples were E. coli positive, and within the hand boundary, about 11% were E. coli positive. And that kind of reflects the rates elevated from baseline. But concerningly, we saw that there was also elevated E. coli contamination rates outside of both of those flood boundaries. And so basically what that was telling us was these boundaries were not accurately capturing all of the flooding, or there was contamination in those wells before the flooding event happened. So we also saw that 80% of E. coli was in 2 clusters. The first was in Wilmington, kind of right where the eye of Florence hit, where we saw really heavy precipitation. And the second was this coastal cluster here, which was likely a result of storm surge. So thinking about different types of flooding, we saw impacts from tidal flooding, which was caused by that storm surge, pluvial flooding, which is just from that oversaturation of precipitation. And then we also need to learn to account for groundwater flooding and fluvial flooding, which is when riverbanks overflood. And that actually became really important after Hurricane Helene. So our main takeaway from Hurricane Florence was that we need to be able to provide informative flood mapping models to health departments, and there's kind of 3 prongs that are really important to focus on. The first is their prediction capabilities, so getting those predictions to be more reflective of the actual contamination that we're seeing, making them accessible within rapid time after the storm. So the FEMA 100-year flood boundary was nice because it was just pre-existing. So before the storm even came, you could say to health departments, look at this map to get an idea of where places might flood. And then the third is accessibility. Like Wilson kind of talked about, the capacity of different local health departments to utilize some of these tools can vary really widely. So making sure that we have a product that's easily accessible for them is really important. And ultimately, we hope that these boundaries can be used to target testing and recovery efforts. So, all that to say, after this study with Hurricane Florence, our remote sensing team took a look at the hand flood boundary and calibrated it to be closer to that 100-year flood map so that we could still have an informative model, but that would also be storm specific. And so our team, Colin and Ed, they did a lot of work to optimize that hand boundary to be able to be more dynamic and user-friendly. we were able to utilize this calibrated hand map following Hurricane Debbie in 2024, where we enhanced sampling and monitoring efforts to determine real-time estimates of flooded areas. So the overarching question here was, can we give local health departments a near real-time flood map? And so, like I said, our team did a lot of work in making this hand boundary very accessible, and it's now in a Jupyter notebook. So if you give it to the health department, all they have to do is put in the dates of interest and a flooding threshold that they might estimate. So say like 1 foot of flooding or 15 inches of flooding. And you could put that into this Jupyter notebook and it'll generate a flood map. So after Hurricane Debbie, we were able to use this method to really quickly create a flood boundary that could be used by health departments. At the same time, I had been planning a sampling campaign in Eastern North Carolina. The idea was to get baseline data so that when a storm came, we had comparable data from the same wells. So you could say, before, this well didn't have total coliform, and then after it did. And this is something that I'd been planning for a few months with 6 different local health departments. And then Hurricane Debbie came the week that we were supposed to do sampling. And so we kind of shifted gears with our recruitment style, and we started to advertise this as a post-storm campaign. And we were able to get on the news, get on the radio, and kind of warn people that their water might be impacted by the storm, by the high amount of precipitation. And in the following week, we were going to be offering free testing. So we were able to validate that flood mapping boundary that I showed through this sampling effort. So you could see there all the kits that we packed. We packed about 350 free well water kits and distributed them to 6 different local health departments. The bottles came with, we actually tested for metals as well. So there was a first draw, a second draw, and then a bacteria sample that we provided to residents. And when we compared this to our flood boundary, we found that there was minimal flooding impacts, which Debbie ended up getting downgraded to a tropical storm, and those results kind of made sense with the impacts that we saw. But it was a really great opportunity to kind of take this flood boundary, take some samples, and estimate them in real time. So we were able to provide data to residents so that they can empower decision-making around their water systems. We also established methods for sampling in these areas, and we can use this data to further validate our research. So both of those kind of worked up to the point that when Hurricane Helene hit in September of 2024, we had this real-time flood map that we were able to provide for decision-making by health departments. So this is just a map of North Carolina. The counties highlighted in yellow there were ones that had FEMA disaster declarations after the storm, and then those dots there are showing the density of private wells. So you can see in Western North Carolina, we saw high impacts, and then there was also a really high density of private well usage. And so this is kind of a timeline of the events. On Friday, September 27th, we kind of reached out to Wilson and our other collaborators at DHHS to kind of discuss needs and develop a plan. As he showed, there was extensive impacts, and at that point in time, they were kind of still in search and rescue mode, and so it wasn't really the time to be like, all right, let's do well water tests. And so after all of the help that our collaborators have given us over the years, this was kind of our turn to say, okay, what can we do for you? And so we together discussed and developed a plan of how we could provide data to them. Over the next week, we gathered and compiled different data sources. This was a really iterative process where we would go back and forth and say, hey, what do you need? We need this kind of data. No, not like this. Maybe more. And so we went back and forth for about a week trying to put together a platform that had all the data that would be useful and was in a format that local health departments would actually use it. And by Monday, October 7th, we were able to disseminate the portal, develop reports, and then make as-needed adjustments. So, as I mentioned, we reached out on the 27th, and the first thing that we went ahead and did, because we had the capacity to, was developed a hand flood boundary for the areas that were impacted by Helene. So we created these estimated maximum flooding extents over the weekend, and then the following Monday started to put together some other data products. So the hand flooding extents was our major real-time data source. And then we also brought in some rainfall data. So using some NASA satellites, we were able to have precipitation totals in 10 by 10 kilometer grids. That was available 12 hours after the storm. So you could say that that point in dark blue there had maybe 30 inches of rainfall, where some of those other areas in the lighter red or green had less rainfall. And then we also brought in some private well estimates. And so this was really cool because we were able to overlay our flood boundary, which is that dark blue running through, with estimates of private well usage. So you could see maybe some areas that were heavily impacted but not reliant on private wells, or other areas that had a lot of flooding and had high well usage. And so we could go to Wilson and say, hey, take a look at this block group in this county, kind of thing. So, like I said, we wanted to establish some recovery priorities and what areas could we provide data in that would actually be useful. And so the first was estimating the extent of the flood boundaries. But then, as Wilson mentioned earlier, there was also this need to get businesses up and running again. So restaurants, daycares, schools, were there municipal areas that were impacted by water and wastewater. Then they wanted to be able to visualize those impacted areas so that we could prioritize distribution of recovery resources, and then ultimately inform emergency response funding requests so that when legislators asked what were the impacts, we could have kind of ballpark numbers. And so we brought in a bunch of other data products. So this is kind of where we got some of those other data from. On businesses, estimated well use, public water and sewer, known sources of release of contaminants. We also brought in some demographic data and land parcel information. We were able to put all of these together, and this is ultimately the design that we came up with. And so you can see all of the different layers that we have there, and I think, okay, yeah. So we had flooded areas, fire stations, open shelters, schools, and this was all part of our decision support system. And then that link in the bottom left-hand corner could take you to the website if anybody is interested in kind of playing around with it themselves. But here I just have a little video showing how you could navigate through the website. So the layers are all up on the right there. There's community areas, businesses, we have the flood boundaries, and you could kind of toggle those on and off. And then you're able to select a county. And so if you're just interested in Buncombe County, all the other counties go away. You kind of zoom into your county of interest. So if you're from a local health department in Buncombe County, you're able to kind of scroll around there, and you see we have our estimated flood impacts. And then that's a school that was flooded, and that is a restaurant that was flooded. So you could kind of click on those and see exactly where there were impacts. You can also change the base map, so you could see like satellite imagery. And this is kind of cool because you could toggle on and off and see where the existing river was and then where we estimated flooding impacts. So you could kind of see that substantial change in water levels there. And then finally, as I mentioned earlier, you can overlay this with estimates of private well usage. So this is in Asheville, so you could see there's a lot of white area initially because those areas are on municipal water. But then as you zoom out, you can kind of see block groups that had well usage. So this is the way that we intended to use this product. And while the support system itself was really cool, the feedback that we got was, okay, this is great. Can you summarize these numbers for us? because a lot of people didn't have the capacity to be doing those estimates on that data themselves. And so we developed these estimated impacts for the total number of community locations, the total number in flooded areas, and then within 100 meters of those flooded areas. And then we also developed estimates for the private wells flooded for each county. Overall, the engagement in our portal was pretty well distributed throughout North Carolina, although you could see the majority of our users were in Western North Carolina, which is good because that was our intended use, was for local health departments to be able to use this in real time. We also saw 40% of our users were within the first week that we launched the portal, and 70% were within the first 2 weeks. So this really was a tool that was used immediately after the storm to get an understanding of what the impacts were. And then this is just another figure kind of showing that engagement over time. You could see that there was a small subset in the block there that were returning users that kept coming back to look at the portal over and over again, but the majority were just kind of looking at it 1 or 2 times and then moving on. Also, as Wilson mentioned before, we developed these reports from that data on the support system to estimate the total private well impacts. As mentioned, we estimated about 20,000 wells were flooded after Helene. That was a pretty rough estimate, but it gave us a number to jump off of really quickly and say, this is what we think happened. We also took those reports and estimated businesses that were impacted and then known sources of contaminants. So above ground storage tanks, hazardous waste sites, landfills, and estimated how those may have been flooded as well to think about how contaminants could have been transported. We developed each of these for individual counties as well. And then we also linked some other resources on our portal website. So some of the videos that Wilson was mentioning, understanding your water quality, how to take a sample, damage assessments, and then how to disinfect your system. So all of these were available on our portal as well as on the DHHS website. As mentioned, these estimates were used in real time. So this is a press release from October 10th. And more than 300,000 people in or near flood impacted areas in Western North Carolina rely on private wells. That was a number that our team generated. So that was a pretty cool example of how this data was used in real time. Also, I wanted to note that this ended up getting attention in the New York Times, which, I think we all know that private wells are sometimes an understudied or overlooked component of environmental health and safe water access. And so seeing this kind of spotlight on private well usage and the amount of public support that happened after Hurricane Helene, it's unfortunate that it got to this point, but it was a nice acknowledgement of the need for attention in this field. So overall, lessons learned. We learned that we need to provide actionable data, but not just data, but intelligence. So the feedback that we got from local health departments was that while the portal was really great, the thing that they actually ended up using was those generated reports. And so if we could find a way to put user-friendly analytics into the decision support system, that could enhance the functionality and usability. So instead of just zooming in and saying, okay, this one area was flooded, we could develop those county level estimates within the portal in real time. And I think that would really leverage the effectiveness of this support system. Also, we need to increase targeted training prior to emergencies. As Wilson was mentioning, a lot of this was done in the fly on real time. And it was a really good lesson because now we kind of know what to do for next time and what data products to have available, what's going to be useful. But getting some of those local health departments up to speed with their GIS capabilities is going to be really important so that they can use this data when we provide it to them. And ultimately, we want to empower local health departments with skills, resources, and knowledge. So some ongoing collaborations that we have, Wilson kind of mentioned a lot of these, videos, educational materials, testing, and then, of course, our team is continually working on improving those data products, so getting better resolution, getting better time latency, accuracy, and user accessibility. These were the videos that we created. Shout out again to Andy Blethen. And then designing and building the wellheads. So when we had the idea to develop these wellheads, we kind of gave Wilson this figure and we're like, what do you think? And working with him, working with some drillers and nonprofits, we were able to put together this design that more reflected what a wellhead is going to look like. So adding the well and pump tags, adding threaded taps, showing the electrical so that users are getting an idea of what their system actually looks like. And so this was an effort that we did with the Catawba water keepers. And we built these mock wellheads in North Carolina and then distributed them to each of the local health departments in the impacted areas. We're also working on aggregating and analyzing some of that data. Like Wilson mentioned, there was about 3,000 wells that were tested after Helene. Our team has worked with some of the other local health departments that didn't do their testing reported to the state, trying to get those numbers and put them into one database. And so we've been looking at wells that were tested, wells that were positive for total coliform, E. coli, and kind of how that testing distribution looked over the weeks after Helene. And then you can also see on that left figure, the shaded area there is the time period when those direct-to-consumer kits were distributed. So you can really see how effective those were in boosting the outreach of testing that we were able to get. So what's next? Continue listening. So our overarching vision is to empower local health departments with GIS-enabled tools. And so, of course, we want to curate data products to create a geodatabase. But the steps needed to get there is an iterative process. So surveys and interactive courses with local health departments, development of training modules. Our team is actually going to the North Carolina Symposium this summer that DHHS puts on, where there's going to be environmental health specialists there, and we can work with them to understand their work and kind of share our work and provide training to them. And then emergency well water testing through local health departments, being there, having boots on the ground, working both with the local health departments and also the residents to kind of gain that rapport, trust, and collaboration going forward. So this is a co-design process that we've been in the works with for many years and are continuing to kind of build off of. Thank you. Questions? Okay, so the first one, your free water testing says confidential, but then you use the results and information for data for public reports. That appears confusing for the well owner. How do you explain that? That's a good question. So when we provide testing, there's a whole packet that we give to the resident that has information on what their data is going to be used for, how we plan to do our research with the data, but any information that's done in public reports is all kind of aggregated, and so none of their personal details or their personal water quality results are released. So you can't say, the well at this address has E. coli positivity, because we know that's something that well owners are often concerned about, especially for things like property values. And so all of that information, when it's reported, is aggregated. Is this data and tools available to the public, or is it for government agency use only? Yes, so the website that I showed is available to the public, and we designed it mainly for the use of local health departments, but there's also some tools in there that could be helpful for well users, which is why we have those videos and other resources linked so that if well users want to use the data and tools, it's completely open for them to use. Any plans to develop this type of model in other states? Yes, but we are funded to do this through North Carolina, and I think our goal is kind of to develop a system that can be easily adopted within other states and build up this platform that could be used elsewhere.
So the rest will have to wait.
Okay.
So thank you. Wait 30 minutes.